In this episode, I want to solve what I would call a trickier type of simultaneous equation. I call it trickier because it can't be done by the routine method of systematically eliminating one variable at a time. So here is how I would do this. So the equations are x plus y times y plus z is 63. Y plus z times z plus x is 54. Z plus x times x plus y is 42. I've written that down as PQ is 63, QR is 54, and RP is 42, where P is the x plus y, Q the y plus z, R the z plus x. You don't have to do this. It is not a necessary step, but for me, it just makes the explanation just a little bit tidier. So I've numbered the new equations as 1, 2, and 3, and if I divide 1 by 2, the Q cancels out, and we've got P over R equals 63 over 54, which cancels down to 7 over 6. And from equation 3, we have P times R is 42. So we got down to there. What I've done now is multiply those two expressions together. So you've got P over R times PR equals 7 over 6 times 42. In this, the R's cancel out, leaving us with P squared equal to 49, which means P is 7 or minus 7. Now, if P is 7, then Q is 9, because Q is equal to 63 divided by P, 63 divided by 7, and that is equal to 9. And in a similar way, R is equal to 6, because that is 42 divided by 7. So P, Q, and R are all positive over there. So let's take the equation x plus y equals 7, because that's what x plus p is. X plus y is p, and p is 7, and similarly z plus y is 9. If we do a subtraction there, we get z minus x equal to 2, and we also have the equation z plus x equal to 6, because that is r. Okay, and then when you add those two together, you'll get 2z equal to 8, and that means z is 4. Okay, and from that same little system of equations there, since z plus x is 6 and z is 4, means that x is 2. So we got down to there. And finally, Q is equal to y plus z. So y is equal to, so x plus y is 7, y is 7 minus x is 2, and so y is 5. So finally what we've got is x is 2, y is 5, and z is 4. That's that bit there. And similarly, in the negative case, x will equal minus 2, y is minus 5, z is minus 4. So you ended up with two sets of solutions, which is what you should expect, because when you multiply those brackets out, you get second degree terms. So that means there will be two solutions. So I hope all that was reasonably clear. Thank you very much for listening.